So today I'm covering section R3, which is rational exponents and radicals. So we are just seeing some rules. The first one is if n is greater than 1, which is an even integer, and then n a is greater than 0, then square root of nth power, nth root is the principal nth root of a. So the example is square root of 4 equals to 2. The second one, if n is an odd integer. So for example, 3. We are finding the third root of negative 8. What that means is when you multiply negative 2, negative 2, negative 2 3 times, we get negative 8. So the cube root of negative 8 is negative 2. So the same thing here, 2 square is 4. And then the third example is nth root of 0 is always going to be 0. So square root of 0 is 0, cube root of 0 is 0. So any nth root of 0 is going to be 0. So we are going to solve examples. So the first one is evaluate. I have number 1, a cube root of negative 64, which is the answer is negative 4. When you multiply negative 4 3 times, we get negative 64. So I have posted videos for how to find the roots. You can use the calculator to find these answers. So I'm just writing down the answer. So whenever you have negative number inside, and this is called the index, the radicals. If this is an even number, the answer is not a real number. It's going to be an imaginary number, which we will learn later. So however, right now, we are just saying this is not a real number. So the next one, the definition of a to the power 1 over n and a to the power m over n. What that means is let a be a real number and n be an integer such that this n is greater than 1. If nth root of a is a real number, then we can write nth root of n a as a to the power 1 over n. So basically the power is 1 here. So the number outside is called the index. And then this is called the radicand. And the square root symbol, this is called the radical. So for example, if you want to convert this 64 to the power 1/3, so the index is going to be the denominator and the number goes inside. Okay. So the next few problems, we are going to convert the expression to radical form. So 2a, I have 25 to the power 1/2. So we know what half means square root. So we don't put the index here. We don't put the 2 here. That's not correct. So the default is, whenever you don't see the number, the default number is always going to be 2. Problem B, I have negative 27 to the power 1/3, which is going to be, so you write the same thing. The 3 is going to be the index, which is 3 goes outside, and then negative 27 to the power 1 goes out inside. And then the answer, you can use your calculator to find. Same thing for all the numbers, we can write the answer here. This is 4, and square root of 25 is 5. And then definition of e to the power m over n. I can write this one as I mentioned earlier, the n is going to be outside, that is going to be a to the power m. So I can write this one as a to the power m to the power 1 over n, or you can switch, you can bring the n inside and you can put the m outside. They all are going to be the same. So for example, I have 125 to the power 2/3. I can write this one as cube root of 125 square. You can write like this, or I can write cube root of 125 the whole square, all the same. So cube root of 125 is 5, so it's going to be 5 square, which is 25. So next one, convert each expression to radical form. So 3a, I have 9 to the power 3 over 2. So I can write this one as, I can write square root of 9 to the power 3. And we know that square root of 9, or I can write the same thing as square root of 9 to the power 3. And we know the square root of 9 is 3. So it's 3 cubed, which is going to be 27. And let's take the next one. I have 27 to the power 2/3. So I can write this one as, you can put the negative outside because it's inside, it's not inside. So I can write cube root the whole square. So which is going to be negative. Cube root of 27 is 3. So it's going to be 3 square. And you have to carry the negative sign. So the answer is negative 9. Next, 4, we are going to convert each expression to equivalent rational exponents. So exponents, we are going to do the other way around. Assume that all variables, represent positive real numbers. So let's take a, I have 2 times cube root of 7 times x. So you put the 2 outside. Only the 7x is going to have the radical exponent. Okay. So 2 is going to stay outside. And b, I have 4th root of 6. And let me put it in a different way. 4th root of 6. And then this x to the power 3 is staying outside. So I can write 6 to the power 1 over 4 times x to the power 3. And this is not radical. And then next we are going to learn how to simplify the expression. Assume that all the variables are non-negative real numbers. So number 5, I have a. So cube root of 8x to the power 4. So I can split this one as cube root of 8 times cube root of x to the 4. And we know that cube root of 8 is 2. And I'm going to break this one down into x times 6. Or I can say cube root of x to the power 3 times 3. So whenever you have this index and the power same, it's going to come outside and only this 1x is going to stay inside. And b, I have square root of 64 x square y. Square root of 64 is 8, square root of x squared is x, and then only y stays inside. And c, I have negative cube root of 27 over 125. So it's going to be negative cube root of 27 over cube root of 125. That is going to be negative 3/5. And d, we have 8 times square root of 18 over 3. Now what we are going to do, we are going to break this 18 into 2 numbers. So one is the perfect square number, which is 9 times 2. this 9 is, because we can take square root of 9, so it's going to come outside. So it's going to be 8 times square root of 9 is 3, so it's going to come outside. Over 3, over 3. So we can cancel the 3, so the answer is going to be 8 times square root of 2. Then the next questions, I have 5 times cube root of 8 x to the power 7 y to the power 5. So that's 5 times. I'm going to split cube root of 8 times cube root of x to the power 7 cube root of y to the power 5. So we know that cube root of 8 is 2. Now I'm going to break this x to the power 7 into x to the power 6 and x to the power 1, because 3 goes into 6. And then again, we can split it into 3 and 2. So we get 5 times 2 is 10. And cube 6 divided by 2 is 2. So it's going to come outside. And only 1x stays inside. And then again, here, y cubed, see this is 3, power 3. So 3 divided by 3 is 1. So it's going to come outside. And then this 2 is going to stay inside. So this is our final answer. And then we are going to learn how to multiply radicals. So I'm doing number 6, multiply cube root of 4 times cube root of 2. When you're multiplying, you can if the indexes or indices are same, you can multiply the radicands inside. So see, these two are same. So I can multiply the number inside, which is going to be 4 times 2, which is cube root of 8. That is going to be just 2. This is 8. Next, we are going to see cube root of 4 times cube root of 2 minus 3. So now we are going to use the just like distributive property for regular numbers. So it's going to be cube root of 4 times cube root of 2 minus cube root of 4 times 3, right? So this is going to be cube root of 4 times 2 because they both are inside the radical. However, if you look at the second one, there's no cube root for 3, so we cannot multiply 4 and 3. That is going to be wrong. And cube root of 4 is 4 times 2 is 8, which is 2 minus 3 times cube root of 4. And C, we have square root of 3 plus x times square root of 3 minus x. So we have two terms, so we have to FOIL. So this is going to be square root of 3 times square root of 3, and then minus square root of 3 times x plus x times square root of 3 minus x times x. Square root of 3 times square root of 3 is 9. This is going to be x times square root of 3 plus x times square root of 3 minus x squared. So these two get cancelled. Square root of 9 is 3. So it's going to be 3 minus x squared. Next, we are going to learn how to add or subtract radicals. So the two radicals terms are called like radicals if they have the same index. So for example, I have square root of cube root of 5 plus 3 times cube root of 5. So I have the same index and then same radicand. Then they are called like radicals. They are more like terms. See, when I have 3x plus 4x, I can group them together like 7x. So it is same thing like that. So we have to look for like radicals. So for example, square root of 6 plus 2 times square root of 6. So the index here is the same because this is 2 here, this is 2 here basically. But you can imagine there is 1 in the front. So you can add these to 1 plus 2 is 3. 3 square root of 6. And then B, the next one is 5 cube root of 3 minus 6 times cube root of 3. So when you check here we have the same index and same radicand. So that means we can subtract the numbers outside. So it's going to be 5 minus 6 is -1 times cube root of 3, which is basically just negative cube root of 3. Next, C, we have 3/5 square root of 2 plus 2/5 square root of 2. So say we have the same index, same radicands. That means I can add 3/5 plus 2/5, and the common is square root of 2. So when we add same numerator, the common denominator, so the answer is going to be just square root of 2. Then D, I have 4 times square root of 3 minus 2 square root of 3 minus 8 square root of 3. So here all the radicands or the radicals or radicands are equal index, or so they are all like radicals. So 4 minus 2 is 2. 2 minus 8, -6. The answer is -6 times square root of 3. And the last problem, E, we have 7 times square root of 5 plus 3 square root of 5 minus 2 square root of 2. So only these two are like radicals. We cannot add the square root of 2. So it's going to be 10 square root of 5 minus 2 square root of 2. So this is our final answer. Because these two are not like radicals, we cannot combine them. So that's the end of R3.